Well, hey there, kiddos. Today we are going to talk about solving systems of equations by graphing. We've so far solved systems by substitution and elimination. Now we're going to use graphing, and we're going to use our calculators mostly to do this. So if you would, make sure you have your calculator before we start this. So a small review really quick. If you'll remember, we talked about this even today, a solution to a system of equations is the point where the two lines intersect. And this is why we always write our answer as an ordered pair, is because it's a point on the graph, and so it represents something. It's not just a number. And we've talked about this too. Does a system of equations always have a solution? No, it does not, because sometimes lines don't intersect. Sometimes I've got parallel lines and they don't even cross. And so the reason we don't always have a solution is because not all lines intersect. So if you look at question 1 here, question 1 asks us to solve this system by graphing, and we're going to do this 3 ways. First of all, we're going to graph on this graph. We're going to look at it, find the intersection point. Then we're going to use our calculator. We're going to look at the table and compare what's happening in the table to see if we can find the solution there. And then we're going to have the calculator graph and find the solution for us. So we're going to do all 3 with this one problem, so you can see they all get you to the same answer. It's just a different method. So before graphing, I got to know the slope and the y-intercept. So this first equation, y equals x, the slope is 1, and the y-intercept is 0. And for this bottom equation, the slope is negative 2, and the y-intercept is negative 3. So I'm going to graph these both. This first one, my y-intercept is 0. That's my starting point. And my slope of 1 tells me I got to go up 1 and over 1 to get to another point. And I can keep doing that. And I can even go backwards and go down 1 and over 1. So I can have points on my graph. And then I'm going to connect those with a line. Hopefully it's straighter than the one I tried to start with here. Let's try that again. You're going to connect them with a line. Use your ID or a ruler or something so that your line didn't look like that first one I tried to draw. So there's our line. And so now I'm going to switch colors, and we're going to graph the other line so we can see what happens. So this y-intercept of this one is negative 3, so there's my starting point. My slope of negative 2 means this time I got to go down 2 and over 1, and I can even go backwards. I can go up 2 and left 1, and I can keep doing that. So I have plenty of points, and then I will connect those with a line. And hopefully you see that those two lines, they intersect. They intersect right here, even though I didn't draw a very straight line. They do intersect at this point right here, and if you'll notice, that's the point negative 1, negative 1. Since that's where my lines intersect, that happens to be my solution. That's my answer. Now we're going to use our calculator to go verify this. We're going to look and see how our calculator will help us solve a system of equations. So you need to grab your calculator. And the first thing we're going to do is we're going to push this button that says y equals, and we're going to type in our equations into here. If you have anything typed in, just hit clear and then we'll retype. So my first equation was y equals x, and then my second equation is negative 2x minus 3. So there are my two equations, and I'm going to compare the table first. So I'm going to go to second and graph. And this is the table of values that is generated for both of those lines that I just put the equation in for. Every single one of these points falls on those two lines that graphed. And here's how it works. The x value is only written once because they all share an x value. And then you have the y values for the first equation and the y values for the second equation. And they make ordered pairs. So like the first ordered pair here is 0, 0 for the first line and 0, negative 3 for the second line. So I'm going to scroll up in my table to negative 2. And the reason I'm doing that is because I know my solution already. I know my solution is negative 1, negative 1. And I need to be able to see that in my table. So I'm going to go up a little past that so we can look at things. So I'm going to fill in my table here. When x is negative 2, according to my table, y is the negative 2 and 1. So my y values are negative 2 and 1. When x is negative 1, y is negative 1, and y2 is also negative 1. When x is 0, my y values are 0 and negative 3. And when x is 1, my y values are 1 and negative 5. So I've now filled in my table, and what I want you to notice is that these two y values right here are exactly the same. That's because that's what lets me know, looking at that table, that that's where my two lines are at the same place at the same time. They're equal there. And because they're equal there, that tells me that's their intersection point, because they have the same ordered pair, -1, and -1, -1. So they're in the same place at the same time. It is solely coincidence in this problem that the x value and then both y values are exactly the same. Then it goes -1, -1, -1. What you want to look for to find your solution in the table is for the y values to match. It's okay if the x value is something different. You want your two y values to be the same thing. That's what tells you that the graph is in the same place at the same time. That's what tells you that's where they're equal. So if you're looking for the solution, that's what you want to look for, the y values being equal. So now let's go over here and let's look at number 2. Number 2 wants to know, if I have this graph of linear equations, which of the following is a solution? So I have these two lines that are partially graphed. I say they're only partially graphed because they only are on the left-hand side of the graph. They're in quadrant 2 and quadrant 3, but they don't extend any further, and I certainly can't see where they intersect. So the first thing I'm going to need to do is extend these lines so I can find an intersection point. That's my solution. Now, do not just take a ruler and try and extend these lines. We want to be accurate with this so we can find the exact solution, and to do that, we're going to use our slope. So this line right here, they were very nice to us, and they gave us 2 pretty points so I can find my slope. And so it looks like my slope was -1/5. So that's going to be my rise over my run. Now, I'm going to use that, and from this point, I'm going to make more points so I can extend my line. So I'm going to go down 1 and over 5. Then I'm going to go down 1 and over 5, and then down 1 and over 5 again. And I'm going to connect those dots with a line. This time I'm not going to try and draw it by hand. I'm going to actually use a line. So there's that line extended. Now let's do the same thing with this line. I'm going to connect my 2 pretty points, and it looks like my slope is 2/4. Well, if it's up 2/4, we know that simplifies to 1/2. So I'm going to use 1/2 to extend my line. So from here, I'm going to go up 1 and over 2. And I'm going to keep going until I have gone to the end of my graph. And then I'm going to connect them with a line. So I can extend. And you should see now that my 2 lines intersect at this point right here. And if you will notice, that point right there is at 10,2, which is answer choice D. So if you run across a problem like this, just extend your lines, find out their intersection point, and then be done. So let's look at number 3. So Mr. Malone's putting money into 2 savings accounts. He has modeled the amount in each account over 40 months on the graph below. Based on the graph, what will be the balance when the 2 accounts have the same amount? Well, they have the same amount right here. That's their intersection point. That's where they're equal. We want to know what that amount is. Well, it looks like it took 20 months to get there, and it is at $300. So my ordered pair solution is at 20,300, but my question only asks for the balance, so it just wants the money. Well, when they have the same amount, both accounts will have $300 in them, and so that's what they're asking for. Just find the intersection point and give them just the part they want. So here are your calculator steps, and we've already talked about this sum. We did this together. So we're going to do a couple more, and then I'm going to let you go so you can enjoy the rest of your evening. But we are going to find a solution using our calculator, and we're going to have it actually go graph for us and tell us what the intersection point is. Now, the very important thing that you need to know is that in order to have a solution, in order to use your calculator to get the solution, your equations must be in this form. If they are not in slope-intercept form, your calculator doesn't understand them. They have to say y equals, otherwise you can't use your calculator. So if they are not written in y equals, you're going to have to change them so that they are in y equals. So if you look at number 4 here, my first equation is in that format. So we're good with that one, but the bottom equation is not. I have got to get rid of this plus 1/3 x by subtracting 1/3 x from both sides. So my equation becomes y equals, now we're good, -1/3 x minus 1. So here are my 2 equations, and I'm going to use my calculator. I'm going to graph them. So I'm going to go over here, and I'm going to go back to y equals. I'm going to clear the equations that are in there so I can type in my new ones. And my first equation was x minus 16, so I'm going to do x minus 16. And then my next equation was negative 1/3 x minus 1. So I'm going to do negative 1 divided by 3x minus 1. And I'm just going to go look at the graph. So I'm going to have it graph the two lines so I can look at it. We could go look at the table if you wanted, but we're just going to look at the graph. So it's going to draw for me. And if you will notice, I cannot see the intersection point. It's almost there, but not quite. And since I can't visibly see the intersection in this window on my screen, neither can your calculator. We're going to have to set our window so that the intersection shows up. So we're going to zoom out over here in this direction. So we're going to press the button that says zoom. We're going to choose zoom out, which is option 3. And we want to zoom over here to the right just a little. So I'm going to arrow to the right just a little, couple clicks, no big deal. I'm going to hit enter. So it will zoom in that direction. It's going to reset my screen and draw my graph again. And now you should notice that I can see the intersection point. So now we're going to have our calculator find it. So we're going to go to second trace, option number 5, and then because we want the intersection point. And then we're going to hit enter 3 times. 1, 2, 3. And when we do that, you will notice it says intersection down here at the bottom of my screen. That's because it's found it. It's right here where this little cursor is blinking. This is my intersection, and this is the value at that intersection. It's 11.25 and negative 4.75. So my solution to this system right here is 11.25 and negative 4.75. That is my ordered pair solution. So let's look at another one. Let's look at number 7 here, because it says up here if there's not a solution to write no solution. Well, let's see what happens if we don't have a solution. These, neither one are in this form, so I got to fix that first. So we're going to do the first one. I have 4x minus 2y equals 4. So I want to subtract 4x from both sides first. So I have negative 2y equals negative 4x plus 4. And when I divide both sides by negative 2, I get y equals, that becomes 2x minus 2. And then this bottom equation, I'm just going to divide both sides by 2, so I get y equals 2x. I want you to notice that these contain this is exactly the same. That tells me they have the same slope, which means they're parallel lines, which means they're not going to cross. But we're going to graph it so we can see. So we're going to go over here, we're going to go to y equals. Our first equation was 2x plus 2, or is it minus 2? It's minus 2, my bad. 2x minus 2, and then my second equation is just 2x. And I'm going to graph those two lines so that I can look at what they look like. Now my window is still in its zoomed out state, but that's okay. I just want to look at my two lines, and as long as they both show up, it's good. Now they're kind of close together, so it's hard to tell, so I want you to do zoom 6 so that it will reset our window back to a standard window that we're used to. It'll give us a little more space and maybe spread our lines out just a little bit. There, now you can see those two lines are parallel. They do not intersect each other, which means I have no solution. So this one has no solution. So let's talk about number 8, just because I want to get this out of our system and I want to have this done. Number 8 asks for the x-coordinate of the solution to the system of equations, and it only asks for the x-coordinate. It doesn't even care what y is. It also says to round to the nearest thousandth. That's your clue that the answer is most likely going to be a decimal. Now look at your equations. Neither one of them says y equals, so I got to fix that first. So let's do this first one. I have 4.8x plus 0.6y equals 4. And I've got to get y by itself, so I'm going to subtract 4.8x. So I end up with 0.6y equals negative 4.8x plus 4. And now I have to divide by 0.6. So I get y equals, well, this makes negative 8x. If I put negative 4.8 divided by 0.6 in my calculator, I get negative 8. And then this 4 over 0.6, it actually comes out to 6 2/3, but I don't want a mixed number, so I'm going to leave it improper, and I'm going to write it as 20 over 3. It's okay because I'm going to use my calculator to solve it. That fraction is not a big deal. So let's take this bottom one and get y by itself. So we're going to subtract 3.2x from both sides. So you end up with y equals negative 3.2x plus 2.7. So here are my two equations, here and here, and I'm going to put them into y equals, and we're going to look at them on our screen. So we're going to go to y equals. Our first equation was negative 3.2x plus 2.7. By the way, it doesn't matter which order you put them in as long as you just have both equations. So there's one of them. The other one is negative 8x plus 20 over 3. So I'm going to go negative 8x plus 20 divided by 3 to make the fraction. And then I'm going to graph both of those lines and look at what they look like. So here's the first one. And here's the second one. So I can see the intersection point. It shows up on my screen. That's good. So we're going to go to second trace, option number 5, and hit enter 3 times. 1, 2, 3. And you will see that my answers, like I said, are these decimals. Because it asked me to round to the nearest thousandth, that probably meant that that was going to happen. So all they want is the x value, which is right here, and they want it to 3 decimal places. That means I got to go to the 4th number after the decimal to determine if I should round up or stay the same. That 3 says stay the same, so my x value is 0.826. That is your x value for the solution. So that is solving by graphing. Using your calculator is the most efficient way to do it. You can either go to the table, find where the y values match, and that's your solution, or if that doesn't work, then actually graph, have it find the intersection point for you. So we're going to practice this in class tomorrow, and I will see you then.